Dear students, your unit 4 is about memory interfacing. So for the memory interfacing, the microprocessor, why it is going for memory interfacing is to access the read and write instructions. The microprocessor needs to access memory quite frequently to read instructions, codes and data stored in the memory. You all know why we are using the memory device in the microprocessor. The purpose of the memory device is to store the data. Okay, so how the data is read and written by the microprocessor is what we are going to learn today. The memory has certain signals required to write into and read it from registers. You know what is registers? Registers is nothing but they are the memory. Okay, so now you all know the primary function of the memory interfacing is that the microprocessor should able to read from and write into the given register of memory chip. So now this is the typical diagram of memory read or write chip. So this one, it has this read and write chip. It has a group of registers. Okay, and you know how many registers it has is 2048 register is seen in this chip, and each register has the capacity to store 8 bit of information. Okay, so now you can see there are two signals, that is the input buffer as well as the output buffer. The input buffer and the output buffer, they are the buffers which act as the temporary storage device. Initially, the input data will reach the memory with the help of the input buffer, as well as the output buffer. When the microprocessor reads a data from the memory, it is stored in the output buffer and it is given to the output data. And you can see there are many signals in this chip. The first one is A11 to A15. Here the address lines from A11 to A15 is decoded. Okay, and we are going to use only the address lines from A0 to A10, that is of 11 address lines. So now you have the chip select signal and also two control lines. They are read bar as well as write bar. So you know the bar signal is used to indicate the lower signal, that is logic 0. So read bar is used to enable the output buffer and write bar is used to enable the input buffer. So now you can see the read bar is used to enable the output buffer, right? So imagine that you have a microprocessor here. So now the memory is connected to the microprocessor. So what this microprocessor want to do is to read the data from the memory. Okay, so for that you are having the read signal which is connected to the output buffer. At the same time, when the microprocessor wants to write a data, okay, it is using the write signal and it is using the input buffer. So by means of the input buffer, the microprocessor will write the data into the memory. So the next one is memory interfacing steps to perform read and write operations. So what are the steps needed to perform the read and write operations? Or the microprocessor should able to select the chip, identify the register, enable the appropriate buffer. So by selecting the chip, what happens? The microprocessor can identify what register it is going to use and after that it is going to enable the appropriate buffer. It may be an input or output buffer. So the next one is timing sequence for the memory read cycle. So in this time sequence, you are using a 16-bit address, and out of this 16-bit address, you're going to use only 11 address lines, okay, to identify the 2048 registers. So now this can be divided into two things, from A0 to A10 as lower address, and from A11 to A15 as higher address. So A11 to A15, it acts as a decoder to generate the chip select signal for the combination of the address logic. So from A11 to A15 is the one which is used to select the address. Okay, so now it also has two signals, IO/M bar and RD bar. So these signals you have already learned in unit 1, IO/M bar. That means we are highlighting IO. IO means input and output device slash M bar. So that means, what is that? M bar. When the signal is low, that signal is interfaced with the microprocessor. You can see the memory, that is M bar, is low. Bar means it is low. So that means you are interfacing the memory with the IO device, and read signal is also low. That means it indicates the memory read operation. You can see we have used 4 time signals, that is T1, T2, T3, T4, and we are using the memory address lines. These are the memory address lines, that is they are using 16-bit address lines. So out of this 16-bit address lines, you can see the first time sequence in T1, the address from A0 to A7 is shared in the bus. Okay, so when it goes to from T2 to T3, you can see the data from memory is being put to the microprocessor. So to read, this is the reading operation means, you know, the data is read from the memory. Okay, so now to read the memory, what are the things the microprocessor is handling? It is handling with IO/M bar. You can see that M signal, that is M bar, means it is low. So you can see from the first time T1, from the T1 sequence, it is kept low until the sequence end. This M bar will be low. That means it is indicating what? Memory read operation. After that, you can see the read bar signal. Read bar also, you know that it is bar means it is low. So in the second sequence, you can see from logic 1, it goes to logic 0 for some time of instance, and then it goes back to logic 1. Okay, so within that time only, you can see the memory MEMR bar, that is memory read operation, is performed by the microcontroller. In the same sequence, the data from the memory is being read by the microprocessor. So this is the timing sequence of memory read cycle. So the next one is the timing sequence for memory write signal. So in this also, you are going to use 4 clock cycles, T1, T2, T3 and 4 is used, and now also it is going to share the 16-bit address lines. So out of the 16-bit address lines, from the lower address AD0 to AD7 is used for transferring the data. So what does the write signal do? The write signal is used to write the data to the memory. Okay, it is not data from the memory, it is used to write the data to the memory. So for this also, there are the signal, the IO slash M bar signal, which is common like that of read signal. So IO bar M, yeah, IO slash M bar means it is doing the operation with the microprocessor is doing the operation with the memory device. Okay, which is common as that of the read signal. So instead of read signal, you have write bar, and you can see the memory is kept low, logic low. At the same time, when the microprocessor is writing the data to the memory, what happens? It is also maintained low for that sequence. And what happens? The next thing is MEMW, that is memory write signal. So this memory write signal, it is used to copy the data to the memory. And also the next purpose of the memory write signal, it acts as the initiative for the input buffer. You know, the input buffer is the one which is used in writing the data to the memory. You can see that 16-bit address is placed on the address bus, and you're using 11 address lines to identify 2048 registers. Lower order addresses, that is from A0 to A10, can be connected to the memory chip that will identify the select register for the EEPROM. The remaining 80-85 address lines are from A11 to A15, which is address decoder. The meaning of address decoder is used to make all the signals to be low so that the chip select signal can be activated. So now you see there are two signals, IO slash M bar. You know the meaning of IO slash M bar, right? So that means whichever the signal is low, which is under activation. So M bar means the memory is interfaced with the microprocessor and also with the write signal. The write bar signal means the microprocessor is writing a data to the memory device. So you can see IO slash M bar and W R bar can be combined to generate the memory write signal MEMW bar, which is used to enable the input buffer. You know the use of input buffer now. The input buffer which is connected to the memory input buffer by connecting to the memory signal WR bar. So the timing diagram is explained in the previous slide. So the data bytes from the address register during T2, and that is written, it is not read, by the microprocessor before the end of T3. And the next topic is address decoding in EEPROM. So what is this EEPROM? Electrically programmable read-only memory. Okay. So there are two types of address decoding. The address decoding can be done by using NAND gates, and also the address decoding can be done by using 3 to 8 decoder, which we are going to see in the later slides. So now this is the diagram of EEPROM. Okay, so this is electrically erasable programmable read-only memory. Okay, and it contains 4098 registers, and each register it has the capacity to store 8 bit of information. So in this EEPROM also you have the address lines starting from A0 to A15, that is 16 address lines. So the lower address lines A0 to A11 is used for transferring the data. The higher address from A12 to A15 is being address decoded. And you are going to use only one buffer, which is called as output buffer. Here there is no input buffer. Okay, so now this output buffer, it contains two signals, chip select bar signal and the read signal, read bar signal. So that means this EEPROM, it has the capacity to read the information from the memory device. The memory device what you are using is EEPROM, not the writing operation is done in EEPROM. Okay, so address decoding is a process to identify a register for a given address. We have the address from A0 to A11 which are connected to the memory chip. They are the lower address lines. And the higher address lines from A12 to A15 must be used along to generate the chip select signal. So in order to activate the chip select signal, the chip select signal should be maintained low. That means this chip select signal should always produce logic 0 as an output. So how it is possible for us to produce chip select signal to be always logic 0 is to maintain the address lines from A12 to A15 as zeros. Okay, so EEPROM has 12 address lines and CS and one read only memory. That is what I said. There is no write signal. And here there is an quas window. You can see this is the quas window which is used to expose the chip to UV rays for erasing the program. Since this is what electrically erasable read-only memory, you are going to erase the program by means of exposing this chip to the UV radiation. Okay, so now once the chip is programmed, it should be safe. To avoid the future damage, what we are going to do, we are going to cover with opaque tap, okay, for to avoid accidental erasing. Okay, so you can see both static, the one we were discussing before is the static memory device, and EEPROM, they are simpler, very similar. The only difference is EEPROM does not require any write signal. So next you can see the types. As I said, the types using NAND gate, the address decoding is possible, or using 3 to 8 decoder, the address decoding is possible. So the first figure shows the output of the NAND gate which goes active and select chip only when all the address lines are at logic 1. So why they are saying all the address lines to be logic 1? Our main purpose is to make the chip select signal to be low. That is, chip select signal should be logic 0. So for that, if we are applying logic 1 to all the signals in the NAND gate, what happens? The output of the NAND gate will be what? If when you give an input as 1, the output will becomes 0. So for that purpose, you are making all the gates to be logic 1. So the next diagram, it shows the 3 to 8 decoder which is capable of decoding different input lines, different input address lines. Okay, so here the theory is quite different. What we are going to do is we are going to connect A12, A13 and A14 together. It may be with the logic 1, and then A15 is always connected with E30, E3. You have three enable signals, E1 bar, E2 bar, E3 bar. Always this E1 bar as well as E2 bar should be grounded. Okay, and E3 bar, the output of the E3 bar depends upon A15. Okay, here the story is a bit different. So now you can see this is the circuit diagram of the 3 to 8 decoder which is connected to the memory device. So here what happens, as I said, the main aim of the circuit is to make the CS bar to be logic 0. Okay, so now for this we have A12 to A15 which is connected to 3 to 8 decoder. The circuit has three input lines which have different logic combinations. The input lines here, they are referring A12, A13 as well as A14. Okay. And the combination is from 000 to 111. Each input combination can be identified by corresponding output lines if the enable lines are active. If the enable lines are active, the enables E1 bar and E2 bar are enabled. How they are enabled? Making them grounded. And A15 should be logic 1 okay, to enable E3 bar. Okay, so now this enable signal, this logic 1 is carried to the EEPROM. It is EEPROM. Okay, so when it is carried to the EEPROM, that means you are carrying only which signal? Logic 0. Okay, so now this logic 0, when it comes here, can you see the bubble here? The bubble means what? It is an inverter. So logic 1, when it travels here, it becomes 0 when it travels through the bubble. So likewise, we are enabling the CS bar to be logic low. Okay. So what does it do? It do only the read operation. Okay. The special signals used by the EEPROM are read bar signal, then IO bar, IO slash M bar signals, as we were learning in the previous session. So when this RD bar as well as IO slash M bar is kept low, what happens? It activates the memory read signal, okay, which is given to the output enable buffer. The output enable buffer in turn, it enables the data to be read through the data bus lines, that is from 00 to 07. They are the data bus lines where the microprocessor will take the advantage to read the data from the memory device. So for the address decoding, I have set an example which is seen in the next slide. Okay, so in EEPROM, it is assumed that the chip has already been programmed. It is already been programmed and can be analyzed in terms of 3 steps. Okay, so it is programmed by UV rays, that you know. So 8085 address lines from A0 to A11 are connected to the pins A0 to A11 to the memory chip. The memory chip is what? EEPROM. To the address of 4098 registers. Okay, the decoder is used to decode 4 address lines. It is used to decode 4 address lines. The address lines of address decoder is what? From A12 to A15. Okay, so the OO, the output of the decoder, is connected to the chip enable signal, that you know the output should be logic 0. The chip enable is asserted only when the address A15 to A12 is 0000. When you are using a NAND gate circuit, all the data are connected to logic 1, so that NAND gate will produce logic 0. So in this EEPROM example, that is from 3 to 8 decoder, you should connect all the signals to be 0000, that is from A12 to A15, so that the output will be logic 0 to enable the chip select signal. The A15 low enables the decoder and input assert the output 00, that is A15 is connected to the E3, that is enable 3. Whatever the A15 has is been carried to the chip select signal. So for EEPROM, we need one control signal, that you know what is that? It is the memory read signal. The memory read is connected to output enable buffer. To enable the output buffer, output enable is same as that of the read signal in the first figure of the EEPROM that we have discussed before. So now I'm going to have some set of example. So for setting that example, the address range of the memory chip can be obtained by analyzing the possible 16 address lines. The logic level on the address lines, that is A12 to A15, must be 0. Remember that always the address from A12 to A15 in EEPROM by using 3 to 8 decoder, that should be maintained 0000 to assert the chip enabled signal. The address lines from A0 to A11 can be assumed any combination from 0 to 1. We don't want to bother about this because you know the address, it starts from 0000, the address, the starting address, and the ending address, it is 0FFF. Strictly it should be 0. 0 is maintained and it is followed by any of the address lines. So in our example, we are going to take the same thing, 0FFF. Okay, that is what I have explained here. You can see So this is the address lines starting from A0 to A15. Okay, so all the addresses, the starting address will be what? That is, as I said in the previous slide, the starting address is what? 0000, 4 zeros. And the last address, the last most address is what? 0FFFH. How it is achieved? So now from A12 to A15, we are going to use 4 address lines, right? So when you combine this 8421 code together, what happens in an hexadecimal thing? 0000 will gives you 0. And here also 0000. You take first from A0 to A3. So for this 0000, it is what? The hexadecimal value is 0. And from A4 to A7, again it is 0. And from A8 to A11, again it is 0. Okay. So now this 0 is always maintained here. You can see starting from the starting address of the address line until the end of the address lines. All the addresses are maintained to be 0 from A12 to A15 in order to enable the chip enable signal, or you call it as chip select signal. Okay, so now you see 1111 is what? It is nothing but it is F in hexadecimal. And 1111 is again F, and 1111 is again F in hexadecimal. Okay, that is what it is given. Let us assume that 8085 places the address 0FFF. It is only 3F on the address line bus. The address 000H goes to the decoder, and the output line 00 of the decoder, O0 of the decoder selects the chip. The remaining addresses FFFH goes on the address lines of the chip, and the internal decoder of the chip decodes the address and selects the register FFFH. Thus the address 0FFFH is it selects the register. You can see the second one. It is what? It has 0 and then F and then F and then F. This is an example for address decoding. So like this, the same example can be modified and can be asked in different types of questions in your exam. So I have prepared the revision questions for Unit 4 also. I think this presentation may help you. If you have any queries about Unit 4, you can just message me in WhatsApp group, or you can use the portal, or even I have created the Google Classroom for you. Those things may help you for sharing the informations and the learning materials. Okay, so in this revision questions, I have compiled from the starting from the 2 mark until it may be a what is address decoding. It is an important 2 mark questions. You can see wherever it came as what means, you know, what define definitions. It probably it has allocated for as a 2 mark question. And even this why memory interfacing is needed, maybe a 2 mark question. And short notes, write short notes. If a question is asked as a write short notes on, it may, based upon the question, the mark allocation may vary. It may start from 4 mark and it may be a 5 or 6 or 7, whatever. Okay, so students, please make use of this presentation and prepare well for your future exams, I hope. Thank you.